Hello and welcome to the mind map about chemical bonds and their properties. Let's start with ionic bonding. In ionic bonding, metals donate their valence electrons to the non-metals. By doing this, the metals become cations and the non-metals become anions. Then there is an electrostatic attraction between the cations and the anions. Ionic bonding forms a repeating lattice structure, as shown here with sodium and chloride. Ionic compounds have high melting points and high boiling points due to the strong intramolecular electrostatic bonds. They also dissolve in water. They also conduct electricity in both the molten and the aqueous forms, but not in the solid form. Aqueous means dissolved in water. This can occur because the ions are mobile. Ionic lattice crystals are also brittle and will shatter when hit. This is due to the electrostatic repulsion. When the layers cleave, two anions come together and the two cations come together, causing repulsion, and this results in a fracture. We've got a diagram here of a neutral atom, and if it gains electrons, it becomes an anion, and if it loses electrons, it becomes a cation. We also have another diagram of what happens when you melt or dissolve an ionic lattice. When it melts and when it dissolves, the cations and the anions become free, and that's how we can conduct electricity. We also have a diagram showing the effect of an external force, causing a deformation and disrupting the electrostatic attraction, creating an electrostatic repulsion, and therefore the crystal shatters. Next, we're going to move on to metallic bonding. In metallic bonding, the metal atoms shed their valence electrons. The metal atoms become cations and the electrons become delocalized, which means not attached to any one particular cation. In fact, we say that a metallic bond is a lattice of cations in a sea of delocalized electrons. There is also an electrostatic attraction that exists between cations and the delocalized electrons. We can see here a diagram of the pink circles with the plus symbols. They are the cations, and interspersed between the cations are electrons that are freely moving, and that is the sea of the delocalized electrons. So if we look at the properties of a metallic bond, we have high melting and high boiling points due to the strong electrostatic attraction between the cations and the electrons. They're malleable and ductile. Malleable means you can change their shape, and ductile means it will drawn into a wire. And the reason metallic substances have these properties is because the cations can slide over each other and the electrons can fill the gap. They can also conduct electricity in both the solid and the molten forms. This is due to the free moving and delocalized electrons. If you put an electron on one side, one would jump off the other side. Metallic substances are also lustrous, which means shiny. This is because the electrons absorb the light and then release it. Metallic substances also have variable hardness, which means that some are soft and some are hard, like lithium or sodium are very soft, and iron, on the other hand, is very hard. This is due to the variable attraction between the cations and the sea of delocalized electrons. Okay, last of all, we move on to covalent bonding. Now in covalent bonding, the atoms share valence electrons to get a full outer shell. The electron shells overlap when sharing, as shown in the diagram here of hydrogen and chlorine. Now hydrogen has 2 electrons in its outer shell, and chloride has 8 electrons in its outer shell, so both are happy. Covalent bonding can have both molecular and network forms. When they're molecular, they have strong intramolecular bonds but weak intermolecular bonds. Networks are 3D and have strong intramolecular bonds. Graphite, on the other hand, is 2D planar layers, which means it's flat. The nature of the carbon bonding in graphite means that there are free electrons between the layers. Here we have a diagram showing the difference between a 3D network and a 2D planar structure. We also have a diagram showing the difference between a covalent bond, which is an intramolecular bond, and a hydrogen bond, which is an intermolecular bond. Okay, the melting point and the boiling point depend upon the structure of the covalent compound. If it's covalent molecular, it has a low melting point and a low boiling point due to the strong intramolecular but weak intermolecular bonding. Covalent network substances like a diamond have high melting points and boiling points due to the strong intramolecular bonding. Graphite, on the other hand, has a high melting point and a high boiling point, again due to the strong intramolecular bonding. Now, electrical conductivity also depends upon the structure of the covalent compound. Covalent molecular is a poor conductor because there are no free electrons. Covalent network is a poor conductor, again because there are no free electrons. But graphite, which is a special type of covalent compound, is a good conductor because of the 4 valence electrons, it only uses 3 for bonding, which means there is 1 free electron per carbon, and this floats between the layers and allows graphite to conduct electricity. Thank you for paying attention. Like and subscribe if you like, and I'll catch you later. Bye now.